If the Milky Way had been located at the center of the Boötes Void, we wouldn't have known other galaxies existed until the 1960s. Think about that. Everything humanity built, every telescope we ever pointed at the sky, every philosopher who looked up and wondered if we were alone, every civilization that rose and fell under those stars, all of it would have unfolded under a sky of almost total darkness. No Andromeda, no Triangulum, no distant spirals of light hinting at a universe beyond our own. Just nothing. This is the Boötes Void, and scientists cannot fully explain why it exists. To understand just how strange this place is, we need to talk about scale. And I need you to stay with me here, because every step is going to feel more absurd than the last. Our solar system, the Sun, all 8 planets, everything out to the frozen edge of the Oort cloud, spans roughly 2 light-years across. Our galaxy, the Milky Way, holds 300 billion of those solar systems. It stretches 100,000 light-years from edge to edge. The local group, our little neighborhood cluster of galaxies, spans about 10 million light-years. Now, the Boötes Void, 330 million light-years across. If you traveled at the speed of light, the absolute speed limit of the universe, the fastest anything can ever move, it would take you 330 million years just to cross it. It accounts for nearly 1% of the entire observable universe's diameter, a single yawning hole in the cosmic fabric. And it is almost empty. Here's where it stops being merely impressive and starts being genuinely disturbing. Based on the average distribution of matter across the universe, a region this size should contain roughly 10,000 galaxies. The universe is not empty out there. It's alive with light, with spirals, with ellipticals, with ancient star systems burning in the dark. The Boötes Void contains fewer than 60. 60. That is not a statistical anomaly. That is not rounding error. That is the universe doing something it is not supposed to be able to do. When astronomers Robert Kirshner, Augustus Oemler, Paul Schechter, and Stephen Schechtman first mapped this region in 1981, one of them reportedly said, and I'm paraphrasing, "There's nothing there," which turned out to be almost literally true. According to everything we know about how the universe forms, grows, and evolves, a structure this empty, this enormous, should be impossible. So today, we're going to find out why it exists anyway. To understand the problem, you need to understand how the universe is supposed to work. 13.8 billion years ago, everything, all the matter, all the energy, all the space itself, erupted from a single point in an event we call the Big Bang. But it wasn't a perfectly smooth explosion. At the quantum scale, smaller than atoms, smaller than protons, there were tiny fluctuations, infinitesimally small wrinkles in the density of matter. Some regions, by pure quantum chance, had just a little more matter than others. And then gravity got to work. Over hundreds of millions of years, those denser regions pulled in more matter. Filaments formed, long highways of gas and dust stretching across the cosmos. Galaxies condensed along those filaments. Clusters of galaxies formed at the intersections, like pearls strung along a cosmic web. What you get, after 13 billion years of gravity doing its patient work, is what astronomers call the cosmic web, the largest structure in the universe. A vast, three-dimensional lattice of glowing filaments and dark, empty voids between them. From a distance, it looks almost biological, like neurons in a brain, like mycelium threading through soil. It is the most beautiful and most violent thing that has ever existed. The voids in the cosmic web, those dark pockets between the filaments, are not accidental. They're a natural consequence of how gravity operates. When matter clumps into a filament or cluster, it pulls away from the surrounding region. The denser it gets, the harder it pulls, and the region it's pulling from gets emptier and emptier. This is how cosmic voids form, not because something removed the matter, but because gravity spent billions of years relocating it. Small voids, regions maybe 50 or 100 million light-years across, can form within the age of the universe. The math works out. Gravity had enough time. But the Boötes Void is 330 million light-years across. Run the numbers. Model the gravitational dynamics. Ask the simulations how long it would take to evacuate a sphere of that size to that degree of emptiness. The answer comes back, longer than the universe has been alive. Not slightly longer, significantly longer. The universe, according to our best models, simply has not had enough time to create this void. This is the breaking point. Every other cosmic void we've ever found fits within the margins of our cosmological models. They're big, they're impressive, but they make sense. The Boötes Void does not make sense. One of three things must be true. Either the universe is older than we think, and our measurement of its age, based on the cosmic microwave background, on the expansion rate, on everything we've built modern cosmology on, is fundamentally wrong. Or, gravity behaves differently at extreme scales, in ways our models don't yet capture. Or, something else created this void. Something our current physics doesn't account for. Let's look at what the scientists actually think is going on.
The leading scientific explanation is elegant, and when you see it visualized, it clicks immediately. The Boötes Void was not born as a single enormous emptiness. It was born as several smaller voids. What was two small voids becomes one larger void, and the combined space is bigger than either was alone. The same thing happened here. 3, 4, perhaps more individual cosmic voids expanded over billions of years. They were each large, but not impossibly large. Each one, on its own, was consistent with the age of the universe. But as the cosmic web evolved, their boundaries collided. The thin filaments of galaxies separating them were gravitationally stripped away. The walls dissolved, the voids merged. What resulted was a supervoid, a composite emptiness that looks, to our telescopes, like a single, impossibly large structure. This hypothesis explains the scale problem. It doesn't require the void to have formed all at once. It only required several smaller, more reasonable voids to evolve and eventually find each other. It is, currently, the best explanation we have. But the most haunting evidence for this theory isn't found in the emptiness. It's found inside it. Of the roughly 60 galaxies that do exist within the Boötes Void, something strange is true of their arrangement. They are not scattered randomly. They don't drift through the darkness in isolation. They form a line. A long, faint, glowing tube of galaxies, a filament, cutting directly through the heart of the void like a spine. Astronomers believe this is a dying filament, a remnant wall, the last trace of the boundary between two merging voids. When the smaller voids merged, this filament was caught in the middle. It's being slowly gravitationally stripped apart. The galaxies along it are being pulled, molecule by molecule, star by star, into the surrounding emptiness. In a billion years, maybe less, it will be gone. The Boötes Void will be even more empty than it is today. We are, in a very real sense, watching the destruction of a cosmic structure in real time, just in slow motion. Now, I want you to entertain a thought, not as science, as a question. As the kind of question that keeps astrophysicists up at night, even if they'd never put it in a journal. What if nature didn't make this hole? In 1950, physicist Enrico Fermi sat down to lunch with colleagues and asked a deceptively simple question. If the universe is so vast and so old, and the ingredients for life seem to be everywhere, where is everybody? We call it the Fermi paradox, and it has never been satisfactorily answered. In 1964, Soviet astronomer Nikolai Kardashev tried to approach that question from a different angle. If advanced civilizations exist, what would they look like? How much energy would they consume? How far could they reach? He proposed a scale. A Type 1 civilization, one that harvests all the energy available on its home planet. A Type 2, one that harvests all the energy of its star. A Type 3, one that harvests the energy of an entire galaxy. We are currently somewhere around Type 0.7. But imagine, just for a moment, a Type 3 civilization. Ancient, patient, impossibly advanced, expanding outward at near light speed, consuming everything in their path. What would they leave behind? In 1960, physicist Freeman Dyson proposed a thought experiment. A sufficiently advanced civilization would eventually run out of planetary resources. The logical next step would be to dismantle the planets themselves, to use all that material to build an enormous shell around their star, capturing every photon it emits. A Dyson sphere. To us, observing from outside, such a star would appear to simply vanish. No more light, no more emission. Just a dark mass in space, radiating a faint heat signature in the infrared. Now, scale this up. A Type 3 civilization, expanding across a galaxy at near the speed of light, enclosing star after star, galaxy after galaxy. In the cosmic timescales we're talking about, hundreds of millions of years, an entire region of the universe could simply go dark. Not destroyed, not dead, harvested. A sphere of darkness, 330 million light-years across, containing the energy output of 10,000 galaxies, all of it captured, contained, and used. The Boötes Void, on paper, fits this description perfectly. But here is where science does what it always does. It asks for evidence. A Dyson sphere, no matter how efficient, cannot convert mass into energy with perfect efficiency. The second law of thermodynamics is non-negotiable, even for alien superintelligences. Every energy conversion produces waste heat, and waste heat radiates in the infrared. 10,000 harvested galaxies would produce an infrared signal that would be, frankly, unmistakable. It would be the brightest thing in that region of the sky. We've looked. There's nothing there. No anomalous infrared excess. No faint heat bloom suggesting hidden megastructures. The Boötes Void is not dark because something turned the lights off. It is dark because the lights were never turned on. The matter simply isn't there. It never accumulated. The void is genuinely, profoundly, cosmologically empty. Which, if anything, makes it more mysterious, not less. So let's be clear about what the Boötes Void actually is, and why astrophysicists consider it one of the most important objects in the sky. It is not just a curiosity. It is not just an entry in an astronomy catalog. It is a stress test for our most fundamental models of how the universe evolves. The void sits at a tension point between several unresolved problems in cosmology. Dark energy, the mysterious force accelerating the expansion of the universe. If dark energy behaves differently than our models predict, if it clusters or varies or has structure, it would directly affect how voids form and grow. The Boötes Void could be a fingerprint of dark energy we don't yet understand. Dark matter, the invisible scaffolding of the cosmic web, detectable only by its gravitational effects. The distribution of dark matter in the early universe seeded the fluctuations that became filaments and voids. An anomaly this large may point to a patch of the early universe where dark matter was distributed in a way we can't yet model. Cosmological inflation. In the first fraction of a second after the Big Bang, the universe expanded at a rate that defies ordinary physics. The seeds of every structure, every galaxy, every void, every filament, were planted in that instant. If inflation was slightly non-uniform in this region, it may have set the conditions for a supervoid hundreds of millions of years before the first star ever lit up. The Boötes Void, in other words, is not a problem to be explained away. It is a message, written in the language of empty space, and we are still learning to read it. For most of human history, we were afraid of the dark. The dark forests, the dark seas, the dark corners of the world where monsters might live, where maps were drawn with the warning, "Here be dragons." And slowly, painfully slowly, over thousands of years, we explored those dark places. We mapped the forests, we crossed the seas, we filled in the maps. And then we looked up. And we found a darkness up there that makes every ocean we ever crossed look like a puddle. A void in space so large that light leaving one side will not reach the other side for 330 million years. A place where 10,000 galaxies should be, and almost none are. A silence so profound that even the universe doesn't have a good explanation for it. What I find extraordinary, what I hope you'll take from this, is not that the void is frightening. It is that we found it. A species that has existed, in our current form, for maybe 300,000 years, barely a rounding error on the cosmic calendar, managed to point instruments at the sky and say, that region, right there, is statistically impossible. Something strange happened there. Let's figure out what. We are the universe becoming aware of its own anomalies. We are the cosmos looking at itself and saying, that's not right. And that, maybe, is the most remarkable thing in all that empty space.